Alrighty, welcome back to chemistry. Today we're going to be talking about the scientific method. Today's learning target is that you will hopefully be able to describe the steps of the scientific method and decipher between an observation and an inference by the end of this lesson. So once you finish this video, make sure you can answer that, make sure you feel confident about that, and if you don't, make sure you just rewatch the video. Before starting this video, you should have already completed your warm-up number 5. What is the difference between an observation and an inference, which we'll hopefully learn today. You will need your note packet for today. We are on page 2 of the note packet. We are going to complete page 2 today for your notes. Just like in the last video about phenomenon, I am going to be using the same PowerPoint for honors and for general chemistry today, but honors chemistry you will have a supplemental video to cover additional material, so make sure you watch both videos for honors. General, just ignore that. So let's get started. Like I think I already said, you've probably already heard about the scientific method. You probably learned it in elementary school. It's probably been hammered into your mind. And if not, that's okay. We're going to learn it now again. So when you think about an experiment, what do you think some important parts of experiment might be? I'm pretending this is like Dora when you're at home and you're answering my questions. So hopefully you're actually answering them out loud, because that's my purpose. So yes, you might answer a question, you might have data, you might have observations, you might have results. So generally, the scientific method, you start with asking a question. Always. You're always trying to find the answer to something. You then do background research. What do you need to know about that topic in order to successfully make an experiment? You then construct a hypothesis. We're going to talk about a hypothesis shortly and how a good hypothesis looks. You're then going to test the experiment and see if it worked. Did it work? No. You're going to test it again. Did it work? Yes. Then you're going to analyze it. What did you learn from it? And you're going to draw some conclusions. One thing I do want to specifically point out is the scientific method isn't a linear process. This isn't a 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 step thing. Notice that something might go wrong and you'll have to go back to step 3, or something might go wrong here and you have to go back to step 2. It's a very fluid process. Science is not a linear thing. You don't ask a question and always get an answer. You have to rethink things over and over again. You might have to retest, you might have to rehypothesize, repredict, use different materials. It's a very ongoing process that is ever changing. And we're going to look at the differences in chemistry, particularly over the course of this year, and how ideas and theories have changed over the course of time. So for those of you that love definitions, the scientific method in general, let me move myself, is just a logical approach to solving problems by observing and collecting data through forming and testing a hypothesis. So just a very wordy version of what I just explained through this chart. Moving forward as well, I do want to elaborate. I will give you some wait time to write notes, but if you need extra time to write notes, just pause the video. So moving on, what makes a good hypothesis? Another Dora the Explorer question, hopefully that you're answering at your home. So what is a hypothesis? What does that mean? Is there a certain format it should be in? Should it look a certain way? Hopefully you said yes. So a hypothesis is a testable statement. It's something you can do an experiment on. And it is always in the if, then, because format. The because might be something new to you. I know Miss Westmoreland really pushed this last year. I think Mr. Lewis might have in physics, but make sure you're including the because. Don't just say, if I water a plant with pop, then it will grow. But why? That because aspect is important. So if I water a plant with water, then it will grow, because it's getting more sugars, so the plant will be stronger. So give a reasoning behind what you think. So as an example, how does playing video games affect hand-eye coordination? I don't know if that's the right form of effect, but we're going to pretend it is. So please write a hypothesis to answer the question, how does playing video games affect hand-eye coordination? If you need more time, pause the video here while you finish writing your hypothesis. Some of you might have written, if I were to play video games 10 hours a week, then my hand-eye coordination would be better than my brother who plays video games 2 hours a week because I have better dexterity in my fingers so I can reach the buttons while not looking at my controller. Or something similar to that. I was thinking about what my favorite video game is right now, and I really can't think about it, but I really think I like the Super Mario Brothers game. I play it on the Wii, and if you press A, you go in the bubble, and it always saves you. That's my favorite video game. Let's continue. So, looking at variables. Sorry, I probably should have put an animation on this slide, but I didn't, so here it all is. So a variable is a factor that can be changed, controlled, or measured. And I know some of you are groaning right now because a variable reminds you of math, and you hate math. Well, really good news for you. Chemistry is just applied math, so super exciting. It's going to be a super fun year for you. But chemistry is really fun. So again, a variable is anything that we're going to be changing, controlling, or measuring. And you've probably heard that there's different types of variables. The first type being an independent variable. So your independent variable, or your IV, is something that you can change or something that you can alter. Again, something that you can change or something that you can alter. So it's what you're testing in an experiment. Whereas your dependent variable depends on your independent variable, and it's what you're measuring, because it's depending on the independent variable. It's what you're measuring. So I don't have examples yet. One moment. Two other definitions that are going to be important for you to know are the constant and the control. So these often get confused in students' head. A constant is something that is held the same during an experiment. Something that's held the same during an experiment. Whereas a control is what the independent variable is tested against. So the control is what the independent variable is tested against. Something you might want to write down is that the control, oh, this is bad handwriting, but I'm trying really hard. The control is what is normal. The control is what is normal. So for instance, if I was watering a plant with Mountain Dew and Dr. Pepper, the control would be the plant I'm watering with water, because water is what's normal. So let's go over some example problems here. So we're going to read the following and decide what the independent variable, dependent variable, control, and constants are. So as I'm reading these, make sure you're following along and identifying those in your own time as well. Maybe if we switch slides. There we go. So a scientist conducts an experiment to test the theory that a vitamin could extend a person's life expectancy. A scientist conducts an experiment to test a theory that a vitamin could extend a person's life expectancy. So what would be your independent variable? What would be your dependent, your control, and your constant? I want you to go ahead and pause the video real quick while you identify what those are. Welcome back. I hope you paused the video. If you didn't, I'm disappointed virtually. So our independent variable. Our independent variable in this situation is going to be the vitamin. Actually, what I'm going to do here is type it right in my slides. Why can't I escape? Oh, look at all my lovely background. This is beautiful. This is beautiful. Alrighty. Oh my gosh. So our independent variable here. Why can't I type? Good. There we go. Sorry, this is not working out as I planned. The independent variable is going to be the vitamin. The vitamin is what we're altering. We're giving people a vitamin that could extend their life expectancy. So we're changing the vitamins we give them. Whereas the dependent variable is going to be their life expectancy. Because a dependent variable is what we measure. We're measuring their life expectancy. A control, so what is normal, is going to be no vitamin. Normally, some people don't take vitamins, so their life expectancy isn't going to be altered if they don't take it. So their no vitamin is the control. And the constant could be a lot of different things. The constant could be the health of the individual taking the vitamin, the sex of the person taking the vitamin. It could be the weight of the person taking the vitamin, or past health experiences, so family health related things. Those could all be instances of what a constant could be. That didn't go as planned, so sorry about that, but I tried really hard to make that interactive. So next, another example. Do tomatoes grow fastest under fluorescent, incandescent, or natural light? Again, pause the video and answer that question independently, please. So the independent variable, I'll just talk through this one since typing didn't go great last time. The independent variable would be the type of light. Is it fluorescent or incandescent? What type of light is what we're changing? We're altering the light we're giving plants, so that is our independent variable. Our dependent variable is going to be how fast the tomatoes grow. We're looking at how fast the tomatoes grow because of light. So we're measuring the rate of growth. The control would be our normal light, because normal light is what plants normally receive. And the constant could be the type of plant. So what strain of tomatoes? Are they cherry tomatoes? Are they Roma tomatoes? Those are the only type of tomatoes I know, but I bet there's more. What kind of soil are we planting them in? How big is the pot? How many seeds are we planting? How much water are we watering them? Are we giving them any fertilizer? If you have questions on independent, dependent, control, and constant, please make sure you reach out. Alrighty, and we are going to pause there, and I actually lied. I'm sorry. Both Honors Chem and General Chemistry, you will have an additional video to watch after this one, so make sure you continue your notes with the following video. I'll see you in that video. Ta-ta!